Okay, in this video, we're going to talk about the sample StatDisk assignment number 3. This is similar to the actual StatDisk assignment found in my math lab. This should help you complete that particular assignment in my math lab. So let's move on to the first sample problem number 1, which is this. A programmer plans to develop a new software system. In planning for the operating system that he will use, he needs to estimate the percentage of computers that use a new operating system. How many computers must be surveyed in order to be 90% confident that his estimate is in error by no more than 5 percentage points? And there are 3 parts to that problem. You want to assume that nothing is known about the percentage of computers with new operating systems. Part B is assume that a recent survey suggests that about 98% of computers use a new operating system. And part C, does the additional survey information from part B have much of an effect on the sample size that is required? Okay, so here we can use the sample size determination in StatDisk to help us answer those questions. So let's go to StatDisk. Okay. Now already you should be logged into StatDisk. If not, then go ahead and register for StatDisk. I do have a video for that in the Getting Started module that shows you how to sign up for StatDisk. All right, now let's go to analysis. That's the first place we need to go to, analysis. And then under analysis, you're going to find sample size determination. Click on that. In this case, we're dealing with okay, I think we're dealing with proportions here. Estimate proportion. Okay, we'll click on that. All right, now you're given 3 things: the confidence interval, the marginal level, and an estimate of P. Okay, and I know we're dealing with an estimate of proportion because I know in part B, it does say 98% of computers use a new operating system. That means we're estimating a proportion, by the way. All right, so the confidence level in that problem, we were told we wanted to be 90%. So if I go back here, let me double check. 90% confident. So we need to change this confidence level from 0.95 to 0.90. 90% is a decimal. You take that 90%, divide by 100, drop the percent sign. That would give you 0.90. Tab down to the margin of error. We want to be no more than 5 percentage points. So if you go back, it says here no more than 5 percentage points in that problem. Well, 5% as a decimal would be 0.05. So we need to type in 0.05 for the margin of error. Now in part A, it says, assume nothing is known about the percentage of computers with new operating systems. So the estimate of P will be blank. The population size N will also be blank. All right, because in reality, the population size is always going to be unknown. Click Evaluate. And at the very top, you'll see the required sample size. In this case, it would be 271. Okay, so to answer the question in our slide here, if we know nothing about the percentage of computers with operating systems, then 271 computers have to be surveyed in order to be 90% confident that his estimate is in error by no more than 5 percentage points. Now, part B, you're given this. We're assuming that a recent survey suggests that 98% of computers use an operating system. So we know something about the estimates. Okay. So now let's go back to StatDisk. The confidence level is still going to be 0.90. The margin of error will still be 0.05. But this time for the estimate of P, we know something about that. We know that 98% of computers use a new operating system. So 98% as a decimal will be 0.98. Population size N will remain blank. Now we click on Evaluate. So this time the required sample size has considerably dropped to 22. Okay, so that answers the question in part B. Assume that a recent survey suggests that 98% of computers use a new operating system. That means 22 computers must be surveyed in order to be 90% confident that his estimate is in error by no more than 5 percentage points. And part C, you can see, does the additional survey information in part B have much of an effect on the sample size that is required? It does, because in part A, we came up with 271 computers based on nothing being known about the percentage of computers. But this time, with 98% of computers using a new operating system, the number of survey needed would be 22. So that means that additional survey information from part D dramatically reduces the sample size. Okay, so that's sample problem number 1. Now, in sample problem number 2, we're dealing with the hypothesis testing question. In a Pew Research Center poll of 745 randomly selected adults, 589 said it is morally wrong to not report all income on tax returns. Use a 0.01 significance level to test the claim that 75% of adults say that it is morally wrong to not report all income on tax returns. All right, so here we have a random sample of 745 adults, and we're told that 589 said it was morally wrong to not report all income on tax returns. And we're using a 0.01 significance level to test the claim. That's 75%. Now, it does not tell you less than or greater than, it just says 75%. So that proportion is going to be equal to 0.75. That will be the claim. All right, so now we're going to go to StatDisk and do this hypothesis testing. Now, we're going to select analysis on the blue strip at the top. We want to select hypothesis testing. Now, we're dealing with percentage here. So that means we need to do a proportion for one sample. Okay, proportion, one sample. Click on that. Now you're going to be dealing with an alternative hypothesis. Okay, and it's going to be one of these three: the proportion, the population proportion not equal to your claim proportion, or the population proportion greater than the claim proportion, or the proportion less than the claim proportion. All right, if P is equal to 0.75, the opposite will have to be not equal to. Okay, so the one we're going to have to select here in this case is not equal to. Okay, so your population proportion will be not equal to your claim proportion. Okay, and sometimes it does help to write out your null hypothesis and also write out your alternative hypothesis, because that alternative hypothesis will tell you, when you write it out, will tell you which one of those three options you're going to need to use. Okay. All right, now we need our significance level. We were told to use a 0.01 significance level. Now they give you 0.05 as a default. So in this case here, we need to change that to 0.01 as our significance level. Claim proportion. Let's say 75%. Well, 75% is a decimal. We're going to use 0.75. And then tab down to your sample size, which is N, that's 745. Type that in, tab down to the number of successes, which is your X, that's 589. Okay, so here we have everything we need to click on evaluate. All right, and this is your output for this. And they also give you the confidence interval as well. Now, and this is based on P not equal to your claim proportion. All right, so here they do give you the sample proportion. They also give you the test statistic and the critical Z value and the P value. Now, I believe in the homework, in the StatDisk assignment, they do want what the test statistic is. This would be your test statistic. To 2 decimal places, it would be approximately 2.56. And then your critical value, notice you have 2 critical values here because of that plus or minus symbol that's in front. There are 2 critical values. One of them will be 2.57583, and the other one is negative 2.57583. And then they also want what they call the p-value. Let's say the 4 decimal places, your p-value will be 0.0105. That would be your p-value. Okay. And then they're going to ask the question. Yeah, they're not going to give it to you directly. They want you to come up with the decision of rejecting the null hypothesis or failing to reject the null hypothesis. Now, if you compare the p-value with this level of significance, if your p-value is less than the level of significance 0.01, you're going to reject the null hypothesis. Look at this p-value, that's 0.0104 or 0.0105. That's bigger than 0.01. So that means we will have to fail to reject the null hypothesis and then make that conclusion here for there was not sufficient evidence to, in this case, since our claim was the null hypothesis, to reject the claim that the population proportion of such arrests in a certain city is different from 70%. Okay, so that's how you would do that particular problem. Okay, take a look at sample problem number 3. The US Mint has a specification that pennies have a mean weight of 2.5 grams. A simple random sample of 37 pennies manufactured after 1983 was selected. Those pennies have a mean weight of 2.49910 grams and a standard deviation of 0.01648 grams. Use a 0.05 significance level to test the claim that this sample is from a population with a mean weight greater than 2.5. Okay. Sorry about that. All right, so now let's look at what we already have here in that problem. Pennies have a mean weight of 2.5 grams, that's mu. Simple random sample of 37 pennies. And those pennies have a mean weight of 2.49910 grams and a standard deviation of 0.01648 grams. And we're using a 0.05 significance level to test the mean, to find that claim that the samples from a population with a mean weight greater than 2.5 grams. So here we're testing a claim about a population mean because we're given mean weight. All right, so now let's go to StatDisk. And of course, if you haven't, I'll do this again. Go to analysis, go to hypothesis testing. But this time, we're going to be testing a claim about a mean. And it's going to be a one sample mean. So we select mean, one sample this time. And for our alternative hypothesis, we're testing a claim that the population is from a sample with a mean. Actually, the sample is from a population with a mean weight greater than 2.5 grams. So in this case, we need to select the one that says mean, population mean greater than the claimed mean. Greater than, okay? If it's less than, you choose less than. If they don't give directional language, you want to assume that it's going to be equal to. So you select equal to. Significance level was 0.05. They give you that as a default, so we leave that as is. Tab down to the claimed mean. In this case, the claimed mean was 2.5. Okay, and that was from the mu greater than 2.5. Population standard deviation is unknown, so we're going to leave that blank. We'll tab down to the sample size. There was a sample size of 37 pennies, so we type in 37. Tab down to the sample mean, which was this number, 2.49910 grams, and the standard deviation was 0.01648 grams. That was given to you in the problem. As I'll show you. Here's the mean. That's this number. Standard deviation was that number. All right, so now we have everything we need. We can click on evaluate. Okay, so here, let's say if they want the test statistic. Here's your test statistic right here. To 3 decimal places, it'll be negative 0.332. And then the critical value is right here. To 3 decimal places, that'd be 1.688. And then if they ask for the p-value, it will be this right here. Also, now this one's 4 decimal places, 0.6292. In this case, that would be your p-value. And then you'll have to decide whether to reject the null or fail to reject the null. All right. If a p-value is less than your level of significance, you're going to compare the p-value with your level of significance right here. If it's less than if your p-value is less than your significance level, reject the null, otherwise fail to reject the null. In this case here, your p-value is much bigger than your significance level of 0.05. So you want to fail to reject the null hypothesis. And if we fail to reject the null hypothesis, that means that there is not sufficient evidence to support the claim. So we can't support the claim that the sample that we're dealing with is from a population with a mean greater than 2.5 grams. Okay. And finally, number 4 is this. A coin mint has a specification that a particular coin has a mean weight of 2.6 grams. A sample of 38 coins was collected. Those coins have a mean weight of 2.59385 grams and a standard deviation of 0.01648 grams. Use a 0.05 significance level to test the claim that this sample is from a population with a mean weight less than 2.6 grams. Okay. So we know we have a mean weight of 2.6 grams. We're dealing with a sample of 38 coins, and those coins have a mean weight of 2.59385 grams. The standard deviation was 0.01648 grams. And we're using a 0.05 significance level, and we're looking for the claim that the mean weight is less than 2.6. All right, so now let's use StatDisk. All right, we're going to go to analysis, go to hypothesis testing. We're still testing a claim about a mean, so we need to select the one that says mean one sample. Okay, so this is what we have here. Under alternative hypothesis, we're testing a claim that we have a mean weight less than 2.6. So we want to select the one that says population mean less than the claimed mean. Okay, and then next would be your significance level. It's still going to be 0.05. Now, if it was 0.01, then you have to type in 0.01, whatever significance level that they give you. Tab down to the claim mean. That's going to be 2.6. Population standard deviations unknown. The sample size, your N, was 38. And then the sample mean, excuse me, will be 2.59385. Tab down to the sample standard deviation, that's 0.01648. And I'm taking all of that from the information which is right here in that problem. And then click Evaluate. And in that particular problem, and I think they do want you to identify the hypothesis, both the null and the alternative hypothesis. And you'll have a choice of options there in that problem. But here, the test statistic is right here. Let's see, to 3 decimal place, that would be negative 2.300. And then your p-value is right here, 0.0136. No, 0.013. Yeah, 0.0136 to 4 decimal places. All right, compare the p-value with your level of significance. If this p-value is less than your level of significance, reject the null hypothesis. So as you can see here, this p-value of 0.01358 is less than 0.05. So here we can reject the null hypothesis. And if we reject the null hypothesis, that means that there is sufficient evidence to, in this case, support the claim. So here we have sufficient evidence to support the claim that the sample that we're dealing with is from a population with a mean weight less than 2.6 grams. Okay. All right, so that's how we apply StatDisk to these particular problems. And this should help you complete the actual StatDisk problem assignment number 30. Feel free to email me if you have any questions about the assignment or anything in this video.